I'm really excited to be here with Tom. As you saw from that video, he is an awesome engineer and social media creator, and he gets to work with both 3D printing and airplanes, which are two things I really love. So I'm actually a little bit jealous that you get to do that all day long. But I think that Tom is part of this new wave of really amazing content being posted on the internet in this kind of fun engineering and educational genre, and I think this is really incredible. Stuff like this, I think, didn't really exist 10 years ago, and it's amazing now that it does. The view counts are crazy. You typically get more than 1 million views, right, on most of your videos, so it's like approaching the scale of popular mass media, but it's showing people useful skills, and I don't know if you think about it as primarily educational, but I think the fact that it's entertaining and useful is amazing, and you should be proud of getting to do stuff, make stuff like that for the world.
Thank you. Yeah, I mean, it's interesting the way you put it as a wave of online. I guess it is entertainment through engineering, and I think a lot of it is grown from the 3D printing aspect of it, being able to make almost any part you can think of at home makes it far more accessible for making these projects for entertaining videos. I suppose back in the day, the equivalent would be shows like Mythbusters, where they would require a lot more tools and resources to build. I mean, their projects were on a much larger scale, but being able to design and 3D print stuff essentially in my bedroom has made it far easier to make these projects to upload to YouTube.
Yeah, absolutely. Between YouTube itself and 3D printing, being able to make content like that is way more democratized, and now one-man operation can do it. So maybe you could tell us a bit about how you got started in this. You studied as an aerospace engineer, but then I guess ended up going a bit of a different path. How did that happen?
Yeah, so I've always been interested in like hands-on making things, basically what I do now. But when I went to study at university, it was a lot more theory-based projects, which I found difficult to start with. But in hindsight, it taught me a lot of the essentials, you know, how to properly design something in CAD. And whilst I was at university, I bought my first 3D printer, which was a very basic FDM machine. And I experimented with 3D printing plain aerofoils, wing sections, and what would be the best way to make them as light as possible but still structurally strong, like the wing ribs and the outer skin and everything like that. And I uploaded, it was probably like a 10-minute video onto YouTube about my experiments with it, and it gained 60,000 views in the first month, which at the time was really impressive. I think I made about $100 from it. And considering I was at the time just working part-time while studying, that was about equivalent to 2 days of work. So I thought that was, you know, there was some potential there.
But were you thinking about it as like this could be a job?
I thought it would be the path to a job of some sort. I didn't really know where it was going to go, to be honest.
And what point did you realize, wow, I could maybe just do this?
That took a little while, yeah. It was more the convincing my parents that I could do that than whether I could do it or not. Yeah, so after university, a lot of my friends did gap year and they traveled around the world. And I convinced my parents that I would do YouTube instead. And they were a bit hesitant at first, but my dad gave me 1 year to make it work. So that was a busy year, yeah.
And you made it work after that, that 1 year?
Yeah, fortunately, yeah.
And how did you figure out that, like, you thought you wanted to make real airplanes and work in aerospace, that was your intended path, right? Like, why didn't you go that way?
Well, I was interested in model aircraft from a young age, and I thought building the bigger planes was a similar path or a similar way of building, but it's a lot more, obviously a lot more strict because there's safety rules and everything like that, and costs, things to be taken into consideration. And I just wanted to just make things like quickly and see something fly, and yeah.
The time scale from actually designing and making and seeing an airplane fly is like 15 years these days, so you're just too impatient for that, I guess.
Yeah, and starting out in the aerospace industry, I won't be designing the actual whole plane to start with. You'd be designing parts towards planes, and then you work your way up. Whereas I just wanted to design experimental aircraft. And that's not really an easy area to go into.
And so you had that first hit with making printing airfoils, and how did you start to figure out what content people want to see or what you want to make? How did that evolve over time?
A lot of the time, it was just things that I wanted to make anyway, and just hoped that other people would find it interesting. It has evolved a bit since then. I have to think a lot more about how this will perform on YouTube. I have to get a certain amount of views and things, which does change the engineering behind it. But I think a lot of the time it's projects that engineers would like to do after work, in their spare time. If they had the time and the printers to do these projects. I get quite a few comments saying, oh, I had this idea a few years ago, but just didn't have the time to do it. So I think that sort of fulfills a thing in the back of engineers' minds.
So you're saying you get to make the things that people dream about making, but
in
they
their
can't
spare
do
time.
themselves.
Yeah.
So they get to.
Well, they can do it. It just takes more time when you have a full-time job.
Yeah.
Yeah.
But they kind of get to have their kicks vicariously through you.
Yeah, hopefully, yeah.
Yeah. Nice. What are some of your favorite projects that you've built?
I've got a few favorite. I think one of my most favorite was a plane that was powered by compressed air. Back in, I think it was in the 90s, Air Hogs released a plane that you pump up and you spin the engine and throw it. And I lost mine on the first flight, so I basically wanted that back. And I spent about 5 years, not continuously, but over time, designing my own compressed air engines and then the plane as well, so that I could have my own one in 2023, I think it was, yeah.
And what was, why did it take so long? What was challenging about it?
A lot of it was the printing technology that I had. I started out with an FDM printer, so I printed the engine out of ABS and then acetone smoothed it. But it was very hard to get accurate parts. Then I used an FDM printer with PLA plastic, and the layer lines were a bit of an issue with the cylinders and pistons. And then the latest engine was printed on the Form 3 because the resin parts are completely airtight, smooth as well for the piston and cylinder, and that's where the performance gains were really made.
I think we have a photo of that one. Should we flip that? Do we have a? You got the clicker there, Mike.
I think
the next one. Yeah, there's the SLA Printed Air Engine. If you guys haven't seen any of this content, definitely check some of it out. It's really, really fun and shows you a lot of what you can do with tools like this. So you were saying having access to the tools, you talked about that a couple times, like that being able to do content like this in general depends on accessible 3D printing tools, and then you've been able to advance what you can do by getting to better tools. That's really interesting. You're currently working on adding another tool that you build yourself to your.
Yeah, I'm currently building a CNC mill for my garage, but I think 3D printing is still going to be the main manufacturing technique.
And what's so great about 3D printing? Why is it the main one?
I mean, for example, with this engine, it would be very difficult to manufacture in other ways, at least at the small scale that I'm doing. For example, the whole cylinder and cylinder head is all one part, and to machine those cavities would be quite difficult. You can maybe cast it, but then you need to machine it again afterwards. And then it's not really visible in this image, but on top of the piston, there's a very small flexible seal. And that was made with 3D printing a resin mold, and then pouring silicon into that to make the seal. So the fact that the whole thing was basically made in one machine is really fascinating to me.
Yeah, and I guess, so you're talking about the geometry flexibility, but also the speed of iteration, I assume, something like,
Yeah.
How many times do you think you've printed this engine?
A lot, yeah. I've got a box probably about this big, just full of them, and the engine isn't very big, it's only about that big.
Yeah.
So probably 30 times.
I think that's such a big deal of lowering the barrier to try something, because you can do it. You could have done it with less iterations, right? But it might have required more careful planning, and might have been more like building a real airplane in terms of
exactly.
time scale. Yeah, so lowering that barrier to try things, I think it's really, really important. Maybe we should click through a couple of these other photos. This is all things that you've done with SLA. Maybe you can explain what's this one here.
So this is an electromagnetic launcher. It uses a similar concept to scale X-straight cars, where these copper brushes would run along metal pickups that would then attract the coil to the magnets and fire it along the rail. This was quite tricky to make because the magnets on the side of the rail attract to each other, so each side wants to bend in quite strong. So the best material I could figure out with printing it was in resin. I tried printing it in FDM, but it would bend a bit too much.
Mm-hmm.
And also when I think it was in the introduction video, when it fires down the rail, the copper pickups, they spark as it switches the contacts, and it looks really cool when it lights up the clear prints.
Absolutely, you see it glowing down the line.
Yeah, exactly. Yeah.
Nice. What else do we have? That's one of the parts.
Yeah,
from
that was
the,
one of the parts. Yeah.
What's
So this was an interesting one. The copper part in the center is fixed to the wheel, and the magnets around the outside and the sprocket, they rotate free with a chain. So basically the chain is only coupled to the wheel via the magnets acting on the copper. But trying to make this is actually a 3D printed sprocket out of rigid 4K. It had to fit within a 25 millimeter, or this whole thing had to fit within a 25 millimeter width, which is about 1 inch. And the bike wheel had I don't know what thread it was. It was like a 32 millimeter 1/4 inch thread or something. It was like an imperial and metric mixed together. But I was able to measure that and then 3D print it in a couple of pieces, which made everything very easy to assemble.
And that sprocket is printed and worked. I think you broke one or two in the video, but you got it working.
Yeah, one of the ones I printed it a bit too thin, so I bought a slightly stronger chain, which allowed me to, instead of running a 2 millimeter sprocket, it was a 3 millimeter, and that held up fine.
But that's pretty awesome to see because it's a polymer part replacing what's typically a steel part.
Yeah.
Very cool. I think we have another. What's this?
This is an air-powered turbine, and then I used essentially a geared flywheel to measure the power output of it. So the turbine would accelerate the flywheel up to high RPM, and depending on the acceleration of the flywheel, I could determine the torque and the power output of the turbine.
But why were you making the turbine? It was for a RC car, right?
Yeah,
air-powered.
Radio-controlled car, yeah.
Nice.
And it's I printed a lot of turbines, yeah. And but it was so easy just to adjust the angle of the blades. You can see sort of through the side of the turbine, just to adjust the angle and see what power difference it makes at different RPMs.
To optimize for efficiency or something like that, yeah.
Yeah.
Yeah, I think wherever there's fluid flow is a great place for 3D printing because you've got unusual complex surfaces and ones that need to be fine-tuned where you can maybe simulate it, but testing, ultimately you got to test it and iterate. Very cool. Is there one more in the deck, or did we?
This was another turbine, which would be basically impossible to manufacture in another way. It's very thin channels that go from the center of the turbine out to the exterior. It may be possible in multiple parts, but in a single part.
What are you excited about working on in the future?
I'm currently working on another bike project. The black frame bike, which I use on a lot of my projects, is sort of my test dummy bike. But I'm trying to make a bike with a motor that it does regenerative braking and then powering the bike as well using supercapacitors. But it needs to be a custom plastic motor. It can't have any metal in it because when you have magnets spinning past the metal, even a non-ferrous metal, even like copper or aluminium, it applies a drag because of the eddy currents induced. So I basically need to make a fully plastic motor, apart from copper windings. There has to be copper windings.
Nice.
But that's the next step.
And it's with a supercapacitor rather than a battery, so it's kind of like doesn't power you the whole way, but it just helps you get up and down hills or something like that?
Yeah. So the idea is that it can be ridden like a normal bike and there's no resistance on the motor. And then when you go down a hill or if you need to slow down, you can charge up the capacitors and then use that to get going again.
Do you, with projects like that, do you hope that they might turn into something useful, into a product, or like it might inspire someone to take it further, or where do you think it can go?
I think
I would kind of interested in that product because I need to not ride an electric bike because it's the only exercise I get on a bike, but I would feel okay with if it was just like, average.
Just used up energy.
If I was putting all the average power in, then.
I think there are some projects which could be adapted to product, but a lot of the projects, it's just to see if something will work. I mean, a bike is very hard to improve on because chains are so efficient nowadays, and you have electric bikes if you don't want to pedal that much. But I think a lot of the projects, they don't have a financial incentive behind them. It's more of the entertainment value. So a lot of the bike projects, in the introduction video, there was I stuck a 10-pound flywheel steel disc in a bike, so that does a similar thing. When I go to slow down, it will speed up the flywheel, and then when I need to get going again, it will then use that energy to then accelerate. Completely useless on a regular bike because it doubles the weight of your bike. But it's just something that's quite cool to explain the physics behind. A bit of energy recovery.
Do you see people picking up some of your ideas and taking them further, or?
I'm not sure, to be honest. Maybe.
What is a good how do you know if what's your measure for is the content successful? Like there's view count, but like what's the what feels the best after you put out a video and you see kind of the response?
I think it does always come down to the view count. That's a big portion of it. But some projects I've built where I'm really proud of it, I absolutely love the project, and it performs poorly on YouTube. Then there's some projects which I have built in a week, and I think, that's not going to do well, and then it goes huge. So it's very hard to gauge what's going to perform well and what isn't. I spoke briefly to you previously. I used to get lots of emails about lots of people wanted me to develop a drone that could fly silently with absolutely no noise. And I thought that's a really complex problem to solve, and it doesn't really seem like it has that much entertainment factor.
Because quiet is not entertaining.
Yeah, it's just a quiet drone. You know, you just turn the volume down on the microphone. You know, but since then, Mark Rober's done a few videos, and there's been quite a few videos on making a quiet drone, because that does actually have a product viability behind it. So yeah, that's an interesting example I found.
I think it's a great project and challenging, and probably needs SLA to do well.
Yeah.
You probably need really nice, smooth surfaces, I assume. Cool. Let me just check my notes. Oh, of course, most important question. What would you improve about 3D printing? What do you want out of our printers or any printers, or where do you want to see things go?
I think, well, reliability and speed have all been, they've all been improved upon. They're all really good. I mean, the fact that you can chuck any design into preform and just have it in a couple of hours is really impressive. I think the only thing that could be improved is, which you're obviously working on, is materials. Because once you can do any material, I know that's probably an unrealistic goal, like at least on one machine. But if you can do any material on a 3D printer, and you just have one machine in the workshop, and you just have a part, and you just click go, and then it's made. I think that will be the dream in the future.
Definitely.
I know realistically that's...
Yeah, any material is tough, but
Yeah.
but better and better materials, and like as you showed with the rigid 4K Sprocket, that like you can, just as the materials get better, you can continuously displace other parts, even if it's not exactly the right material. Yeah, we that's usually my answer as well, for like the single biggest unlock in 3D printing would be significantly better materials.
But like you have the investment casting stuff out on display out there, so you can make metal parts using the resin prints.
It's more than, it's a 3D printing and then sort of extensive manual process. It starts to lose the, I had an idea and made a digital design and printed it, got it out. You said, it sounds like you said you're satisfied with speed and reliability, but like, what if it was even faster?
I find my designing needs to speed up as well then.
The CAD now takes longer than printing,
Yeah.
even for relatively small things.
There's a bit of management to do with, I'll look at what part needs to be printed first, and I'll stick that on print and then work on the next part. So then if the printing is 20 minutes or something, I don't have time to design the next part. And then there's other processes that need to speed up.
Nice. And what else can improve about the workflow? Just like anything about saving time or make it easier to use, or is that all working well for you?
I think it's all pretty good. I think the only
You're
other...
easier to please than some of our customers.
Maybe. I think the only other aspect is to have, which I don't know how you would do, but have, a lot of the time you have to design stuff depending on how it's going to be supported, or how the resin will drain out of it, or anything like that, and having more freedom with that, so you don't have to design for manufacture, you just design for the design, that aspect of it.
Absolutely. Yeah, we just released the drain hole feature in Preform, which helps to address that issue, where you can, still might need to consider it, but at least you can add the drain hole sort of after CAD, after you figured out the orientation. But getting to that dream of like, you can throw any 3D geometry at it and get it out, that's the goal. But you mainly use FDM and SLA, you haven't used SLS yet, have you?
I haven't yet, no.
Yeah,
No.
the SLS is pretty nice. No support structures. Still got to get the powder out, but gives you even more geometry freedom. So you gotta try that out.
Yeah, definitely.
Cool. What else want to cover? Where do the ideas come from? Do you have like just like a big list of things you want to work on, or how does it? Yeah.
I used to create lists, but I find I like to just make things based on what I want to make at the time. A lot of the time I'll take two things and combine them. So one of my early videos was during the time when electric skateboards were quite popular, and you could buy DIY electric skateboard kits. I wasn't very good at riding a skateboard, but I like bikes, so I thought if I'd take one of those kits and put it on a bike, it's a relatively easy project. There were some issues because a bike wheel is far larger than a skateboard wheel, so gear ratios were a problem. But with some 3D printed pulleys and some motor mounts, I was able to make an electric bike using a skateboard kit, and that performed really well on YouTube because no one else had done it at the time. So it's projects like that where you take two ideas and merge them,
remix them
in a strange way.
Yeah, well, that's I think how a lot of invention happens in the world, remixing ideas. What about like comments or things people ask you for, or is there any interesting input that comes from there?
I get a lot of suggestions about how to do things better.
Suggestions?
Yeah, but the thing people don't realise is that the whole point of prototyping is you learn from the prototype to make something better. So
of course they can tell you after you've done
after
this
I've
thing.
made it,
Yes.
you can tell me how to do it better. So, it's of course the second prototype should be better than the first one, but I didn't know that before.
People on the internet are so helpful with their suggestions.
But no, the comments in general are fine. Yeah, no, I normally learn quite a lot from them because a lot of them are engineers that watch it in their spare time. So it's good to read the suggestions.
Cool. Well, I think we are coming to the end of our time, and Tom will be around for the rest of the day. Come and chat with him about his projects. And thank you so much for joining us.
Thank you for having me.